Did you know that tangent inverse of 1 plus tangent inverse of 2 plus tangent inverse of 3 is equal to exactly pi? Well, if you did not know this, then welcome to this video. I'll be proving this fact in this video. And even if you do know this, then consider watching if you have not seen the geometrical proof for it. It's really cool. Now, to get things started, we're going to start by considering a right triangle, okay? A right triangle with side lengths 1 and 3. And here's the right angle, okay? Now, because this is the right angle, this is the hypotenuse. And by Pythagorean theorem, this hypotenuse has side length root of 3 squared plus 1 squared. That would be root of 10. Now, our next step is to construct a larger isosceles triangle on this triangle, on the hypotenuse specifically. Consider this. We're going to draw a perpendicular line to this hypotenuse. So this is a right angle. And we're going to make it so that this length also has length root 10. All right? Now, we're going to connect these two endpoints. And because this is root 10 and this is also root 10 and this is a right angle, when we connect these 2 points, we actually get an isosceles right triangle. Very, very cool. We will now extend this segment upward. And we'll extend from this point a straight line towards the left, such that these two lines meet at a right angle, as shown. So we have a right triangle on this hypotenuse length as well. Now, this hypotenuse length has length root 20 because of Pythagorean theorem. This squared plus this squared, and then take the square root. Now, we need to somehow get more information about this upper triangle. How can we do that? Well, consider drawing from this line a perpendicular down to meet with this baseline, okay? Now, consider this. Let this angle be theta, okay? Then this angle over here is 90 minus theta, right? Because they add up to a straight angle. Furthermore, this means that this is theta. And obviously, this over here would be 90 minus theta. So we see that these two triangles, so this one and this one, are similar because they have same angles. But what's even cooler is that they both have a side length of root 10, and they are literally both the hypotenuse length of both of these triangles. So this would mean that they are actually congruent triangles, not just similar. Okay, so you can test it for yourself. Set up the proportions if you're really not sure. So, because they are congruent, we can conclude that this length has 1 because it matches with the 90 degree minus theta side. You know, this side and this side matches. And this side over here has length length 3, okay? Length 3. Because this has side length root 3, sorry. This has side length 3. This side length has length 2 because they have to add up to 3, right? Now, this would mean that by Pythagorean theorem, this length has length 4. You can calculate it for yourself. Now, this is where the magic happens. If we were to take this angle, I know it's labeled 90 minus theta, but ignore that for a second. If we were to take this angle and label it A, and if we were to take this angle and label it B, and if we were to take this angle and label it C, then consider this. What's the tangent of A? The tangent of A is opposite divided by adjacent. 3, right? Now, the tangent of B, this over here is, again, opposite over adjacent. That's just 1. I know that's 45 degrees, but still write it as this, okay? So we have tangent of A and tangent of B. Now, tangent of C is equal to 4 divided by 2. That's 2. So we have this, right? Now, because of this, A is equal to, well, maybe I should write it like this. I should definitely write it like this for consistency. B is equal to tangent inverse of 1, okay? And we have C is equal to tangent inverse of 2, right? And finally, we have A is equal to tangent inverse of 3. Now, if you were to add them all up, A plus B plus C is equal to tangent inverse of 1 plus tangent inverse of 2 plus tangent inverse of 3. But notice this, visually, they add up to a straight angle, which in radians is pi. So we've concluded that tangent inverse of 1 plus tangent inverse of 2 plus tangent inverse of 3, this is equal to exactly pi. Hence proved. We've proved our original proposition. If you learned something new from this video, then please do consider dropping a like and subscribing. Thank you very much.